You ready? Any
I
other
am.
questions? You ready?
No, no questions.
All right, dude. Well, here we are. We have our podcast guest today. We have Piero Giuffra, right?
Giuffra.
Giuffra. Giuffra.
Giuffra.
Giuffra. All right.
Yes.
He is a master's student. He's studying prehistoric
PhD.
PhD student. He's a PhD student
Okay, there we
studying
go.
whales. Um, he is very knowledgeable guy. He I met him actually in a bar. He was singing ACDC, and Piero, I wore this in honor of you. Rock on. So yeah,
Beautiful.
man. Thank you for joining us, man.
Oh, my pleasure. Absolutely. It's
So,
been
Have you ever been asked to join a podcast and talk about whales?
no, never. This is my absolute first time doing anything like this.
awesome.
And I always wanted to do something like that because I who doesn't like to talk about themselves, right? But at the same time, I also love talking about whales and research and paleontology in general.
Mm,
So yeah,
awesome. Well,
it's very cool.
I kind of want to jump right in and say, what can you tell me about undulation and how that is? Have whales always used undulation?
Undulation
Un
is it's a very it's not as widespread as you may think because
uh
undulation is not really the way in which whales swim because undulation, comes from the word onda, wave,
uh
and in order for an animal to be um, precisely undulating its body to swim, it needs to complete a complete sin curve, right?
uh
However, what cetaceans are doing is they are oscillating. So the tail moves up and down, but it's not that their whole body creates a wave. So
Interesting.
animals that would be um undulating their spine are more like snakes, perhaps,
Oh,
which are often regarded as anguilliform locomotion. And in whales, it's a different scenario.
wow.
Because
Oh,
instead of like if you just picture an animal that is undulating, it's going like this, whereas whales would be doing something like that.
can I just acknowledge that that was like really smooth how you did that
Yeah.
with your head? How many times have you done that?
Well, a lot because and actually if you go see the TED talk, I do it so many times it feels like a barrier between me and the public. I'm just shielding myself between because there was some discussion about the swimming styles of particular cetacean, and I was trying to recreate how this animal moved.
Uh-huh.
So yeah, you can also use like a ruler to visualize it. Instead of doing this, this would be like undulating, whereas
Uh-huh.
whales are more doing something like this.
Okay. Interesting.
Yeah.
Amazing demonstration. I'm like awestruck right now. That is so smooth.
There is actually a whole terminology on different swimming modes. You get well, there is one called the tuniform locomotion that comes from tuna, in which only the tail is moving. So it will be something like this.
Mm.
And this is what some dolphins do. There's also something called carangiform swimming or subcarangiform swimming, in which uh, the two posterior thirds of the animal are moving, and then you get like if this is the body, you do get some pelvic oscillation, and the caudal oscillation is what per, uh, is producing the most amount of thrust,
Oh.
and whales tend to do that.
Now,
what's your
oh,
favorite whale? I just gotta like ask this straight up. Like, do you have like a tier list of whales?
Yeah, I do. I think it's. I mean, it's very straightforward in my case. I am in love with humpbacks. I think humpback whales are the most beautiful animal in the planet. They they are so different from all the other cetaceans uh, in terms of their behavior and social structure. It's absolutely wonderful what they do. Um, so you, as you, I mean, if you picture a whale, you're gonna be picturing something like a blue whale, perhaps. Their fins, even though gigantic, are not participating in the production of forward force, so like thrust. They are most like rudders. They help them to steer. However, in the
oh.
case of humpbacks, they have this massive wing-like fins. Actually, their name means mega wing, megaptera, and they use them to produce thrust. They are actually flying like a stingray, like a manta ray. They are flying with those mega wings that they have, and they become extremely maneuverable because they feed in different ways than most whales. They use bubble net feeding. They circumnavigate the banks and schools of fish to drive them to the surface and accumulate them. And in order to do that, they need to basically do acrobatics underwater, and those same acrobatics are visible when they are in the mating rituals that they have. They dance with each other. They start rotating and moving their hands like if they were singing, and they actually start singing. I am absolutely baffled by this animal.
Don't they travel just incredible distances? Or
Yeah,
is that the gray whale?
no, the humpbacks do travel more. The gray whales are more of a high latitude traveler.
Okay.
They are in California, for instance, but then they go up to the Arctic. Whereas humpbacks, well, you do get them everywhere, and they travel from the Caribbean to the Arctic, and also from the uh, Pacific equator to the South Pole. So they go to warm waters to breed, to give birth, and then they go to the feeding grounds, which are in the very cold waters of higher latitudes.
Why are the feeding? Because I would assume that like there would be much more things to eat in uh in smaller in lower latitudes, but why is there just a higher propensity of just plankton
The
in higher
Yeah,
latitudes?
yeah. There is a higher influx of diatoms, which are the base of the food chain in the Arctic and Antarctic oceans, and they prefer the colder waters. So the colder waters tend to be more productive in
Uh-huh.
this manner. So they feed, they gain a lot of weight in there, and then they go have their infants in the where it's warm and sunny, and mostly because the infant needs to gain fat very quickly, and it's very hard for them to survive in the cold when they are very young.
Oh.
But yeah, humpback is
Have
one of them,
you
but the other one is orca here. I mean, it's very. These guys also are absolutely wonderful animals.
have you got to see whales in person? I would guess that you have.
Yeah. Well, not as much as I would like to, but
Huh?
I have definitely done that. Ooh.
For academically related, was it like a field
Mhm.
experiment or just for fun?
No, no, just it was an accident actually. I was in the northern coast of Peru, and it was mid-October, perhaps. And at this time of the year, the whales are going towards the equatorial waters. Um, no, they are actually going towards the Antarctic waters. They are returning from their breeding grounds. So sometimes we see them with a calf swimming right next to the mother.
Mhm.
And we were just like at the beach, and you see this massive white arm stretching out of the surface. And they do that because sometimes they first they want to cool off a little bit, or they start slapping the water to get rid of barnacles and other parasites. And sometimes they do it just for fun.
Why? So, I mean, it's crazy that, um, like, because you were talking about the dancing earlier, the mating, the singing. How in your prehistoric research, like, have these whales, have they always been intelligent? Were they more intelligent in the past, or are they mo the most intelligent now? And why have they evolved to become so intelligent?
Well, the intelligence of whales is something that has existed for a long time, definitely. Because animals like humpbacks, they have existed for close to 7 million years. And odontocetes, on the other hand, which are the toothed whales, they have had massive brains since even before this, 20 million years perhaps. And
Whoa.
we see animals that already have very large brains in the Miocene, in at the start of the Miocene, which is around 20, a little bit more than 20 million years in the past. Now, the reason why that happens, it's very hard to answer something like that. It's like saying, okay, so why exactly did we evolve intelligence? It's not
Yeah.
something that you can just pinpoint.
Uh-huh.
It's a consequence of several different variables. Sometimes can be just a byproduct of how they're shaped and how large their brains need to be.
Mhm. Now, how did you so you said that you saw, you saw the whales in Peru, but how did you fall into this? Did you see like a cool, Louis Theroux documentary or whatever, or Planet Earth, or
I remember when I was very little, uh, my grandmother gave me a sort of documentary movie. I actually don't remember the name of it. It was so long ago. But I didn't really know anything about whales. I I knew they were beautiful, aesthetically pleasing at least, but there was nothing that really, really made me say, "Holy shit!" Like this is an absolutely fascinating thing that I want to get more involved with. But then I saw the video and I saw them jumping and hunting, and it just occurred to me, well, I didn't choose to study whales at the particular moment, but it definitely made an impact in how much I like these things.
whoa. So would you say that maybe the whales chose you?
Maybe. So my teacher actually, I have a teacher back in Lima.
Uh,
His name is Mario Urbina. Sometimes he says that he finds so many fossils of whales because he has met them in another lifetime, and they are just coming back together.
whoa.
And it's well, it's a wonderful thing to think of. It's very poetic.
Mhm.
Um, but yeah, it's my research does not really aim to observe and study living cetacean. It's more towards the earliest whales that we can see. And Peru is very well known for that. We do have a outstanding amount of material that is being published as we speak, and there is much more to go.
Whoa. Um, Side note too, I heard that there's a valley in Egypt. It's called the Valley of Whales as well.
Yes, yes, that is
Have
correct.
you been there to study as well? No.
No, I've never been to Egypt. I've never been to Africa. I would
Mm.
love to do it. I have some friends that are involved with that in
Uh-huh.
the University of Mansoura in Egypt. And yeah, I mean, I've been with them in the conferences, and we've discussed several new specimens that have uh, been unearthed in Peru,
Mhm.
and it's always fascinating to see another window into this world, because I'm very used to how it looks in Peru. But then in the Fayoum in Egypt, you see very similar rock formations. You see very similar faunas as
Mhm.
well. There are some differences that are obvious, but it's very interesting to see how something I know so well can be, well, not replicated, but was also occurring
Mhm.
in such a distant place.
Didn't they in Fayoum didn't they kind of flood that area and put a reservoir there or something? Or it,
I
I
wouldn't I wouldn't know.
mm,
Like flood back the Fayoum. Because it is a depression. It is a basin. But I don't know about anyone flooding the Fayoum.
okay. Um, so what does your research, so what are you trying to, I guess, kind of dig deeper into in your study of the prehistoric whales? Like, are you trying to kind of find kind of a missing link somewhere, or is there some sort of specific aspect about an ancient whale?
Yes and no. Because
Mm,
okay, so we need a bit of context before that.
uh-huh.
Whales are much older than anything that you would consider a whale. So when you think of a whale, you think of an animal that is big and is swimming in the ocean, definitely cannot return to land. But they are mammals. They are mammals that actually are very closely related to hippos and cattle and goats and pigs. They are in the same order of mammals, which are the even-toed ungulates. And that means that the earliest whales were terrestrial animals, and they were probably living alongside rivers. And we know that this happened in a specific place. This was in the shores of what is now Indo-Pakistan before the subcontinent of India collided into Asia and constructed the Himalayas. This was a shallow sea in the Eocene. The Eocene is from about 54 million years ago until 33. So this was happening around 50 million years ago. And the first animals that we would consider something like whales are the ones who started to become cosmopolitan. So the ones that left that area, the ones who could go into the ocean and not rely on land anymore. And the first family that actually was not able to return to the land is called the Basilosaurids, the Basilosauridae, which are called like that because when they first were found, they thought that these guys were lizards or snakes, hence the name Saurus in the taxonomic group. Later on, it was discovered that they were indeed mammals, and they are fascinating things because it is the first mammal overall that gained complete independence from the land. It was the first
Whoa.
mammal that went fully aquatic. Well, fully aquatic is a term that is a bit ambiguous to some people, but the first big mammals that could not return to the land. And this had huge consequences because mammals have very high metabolism. Mammals are very smart, and mammals have a lot of energy requirements. So a predatory mammal is definitely a massive influence on any ecosystem, more so if they are the size of a house. Uh, so suddenly we had an empty ocean after the extinction that wiped out the non-avian dinosaurs and their lizard relatives that were swimming in the oceans, and the sea was mostly vacant. And there is a very nice documentary in the BBC called Whale Killer, which is the story of female Basilosaurus and her quest to basically survive in this changing world. And the introduction to that documentary is that the oceans were devoid of predators for close to 20 million years. There was nothing around to eat the sharks. And then giant, fully marine macrophagous, macroraptorial cetaceans come into scene. These animals were extremely carnivorous. They were not filter feeding. They were actively targeting, killing, and processing large animals. And this is where the story begins. They kind of look like this. I don't have a model, but I have a skull 3D printed here. Of course, this is just a small version of it. As you can see, these are not the teeth of an animal that is just filter feeding. This is an animal that was actively targeting prey, and this skull is around 5 feet long in life, the actual
Wow.
one. And the estimated bite force that it has uh, surpasses the one that is calculated for the orca. Is larger than the bite force of some carnivorous dinosaurs as well. And yeah, as I was saying, this is the family that first became worldwide and successful and everywhere. And in Peru, we have one of the biggest uh, examples of this diversity. And what I'm trying to understand, or at least investigate, is how does this diversity look early in this evolutionary explosion? Because the Fayum is a place that is very well understood, but the Fayum is towards the end of this explosion. In
Mm.
Peru, we are seeing more and more evidence that we have the earliest of the steps in this explosion. Um and there is a lot of fossils that are not known in the literature. They are not published, but they are already there. They are already found. And I have been cleaning them. I have been looking at them. And what I'm doing in my research is trying to describe these animals and try to illustrate how they lived and what can they tell us about the diversity, not only taxonomic, like which are more closely related to which ones, but also how the how the lifestyles of these whales uh, were like and how they influenced the oceanic environments and they were invading. So it's a bit of a macro evolutionary thing and a bit of it's not something extremely particular. It's not just a single species that I'm looking at. It's a whole revolution in the ocean that started with animals that look like this.
Do
Wow.
you think the land Wait, sorry. What's the name of when the whale was on land? What's that called? Or is there not a name?
No, the first whales that were terrestrial are called the Pachycetids.
Okay.
Paki from Pakistan,
Huh.
because that is where these animals were found, and cetus from cetacean, the Pakistan cetaceans, essentially. And
Is
you have a variety of forms. Some of the, well, forms in the way in which animals themselves are forms, because you do get multiple genera, but they more or less kind of look the same. They are very wolf-like in their aspect.
I was gonna ask, like, at what point did the tail, like you got the classic famous whale tail? Was there any form of weird looking tail when it was on land? Or was that purely when it just became fully aquatic?
That is purely a fully aquatic trait, and we don't know exactly when it started, but by the time that whales were unable to return to the ocean and we had the basilosaurids, we know that at least some basilosaurids already had this tail. But the reason for you to develop this tail is very particular. There is a huge deal with it because these early cetaceans, they were not swimming with their tails. They were swimming with their limbs, like like a dog when you see a dog
Yeah, yeah.
swim. And this is drag related. So they rely on drag for their locomotion. It's like when you're swimming and you're using your arms. This is drag
Mm.
locomotion. The the flukes on a whale, they are not aiming to produce drag at all. They are actually hydrofoils and they produce lift. So lift-based locomotion appeared as the limbs of these earlier cetaceans were starting to be reabsorbed because uh, lift shape locomotion is close to 60% more efficient, or perhaps more, than drag related locomotion. And this allowed the whales that were already in the water to compete with animals such as sharks that are also lift based. That they are not dragging, they are not swimming like a sea lion, for instance, or an otter. An otter is swimming via drag, is using their hind limbs to basically paddle a little bit, but also kick. And this is this is wonderful if you want to be maneuverable and shallow water foraging and hunting. But if you want to travel the ocean, you better rely on lift. And this is where we see this feature appearing. And we can, with some confidence, correlate it with the reabsorption of the limbs and also the presence of some bones in the tail, in the ventral part of the tail, so that they are below the vertebra in the tail that are called the chevron bones. So if you see a skeleton of a whale, you're going to see that right below the bones in the tail, you see this V-shaped small bones that are basically attachment points for uh, musculature that
Mm.
moves the tail down. So we see those things appearing before the basilosaurids, but still we don't have evidence of them possessing a fluke. They were perhaps transitioning towards one, but we don't really have clear evidence that they had it. So protocetids being the immediate ancestors of these basilosaurs, more aquatic than a walking Pachycetus, but not yet completely fully aquatic.
Now, what was, I mean, you said that there were no, natural predators for, I mean, there weren't, or would you say like there weren't a ton of predators in like those 20 million year period?
There,
Or
well,
or you said there were sharks. There were like the
yeah,
megalodon.
yeah.
Um, so I guess is that kind of a motivation of them initially going into the ocean? Did they see that there were a lot of predators on land and they're like, we're gonna try to spend as much time in the water to get away from these bigger predators? Or what was kind of the main motivation of them making that switch?
Well, it's close to impossible to know what they were thinking. But I would say it's 100% impossible to know what they were thinking. So in terms of motivation, I wouldn't call it motivation at all.
Mm,
I would just call it convenience.
mm,
They lived in an environment that favored animals that were more able to swim, but there was no motivation behind it.
mm.
Evolution works by selecting uh, a diversity of forms that are more that dwell better in the environments that are present at that moment.
Yeah.
But it's not a teleological process. It's not something that has a goal.
Mm. So they came in, they started eating the sharks. What came of the sharks then?
So they started eating some sharks. Sharks
Mm,
are extremely diverse, and there were very large sharks back then.
mm,
The the lineage that ultimately produced the megalodon shark was already present in the Eocene. So the genus is nowadays is more popularly described as Otodus megalodon. That would be its scientific name. Otodus actually means ear tooth because the I really don't know why, but the teeth are around this large,
oh my God.
and and some of these forms started in the Eocene around the same time that whales became fully aquatic. It was not the size of a megalodon, but it was bigger than a great white shark, much bigger. And and probably this animal was actively hunting the early whales. And there is it's possible that sharks became even more diverse after the whales came into the scene because they were feeding on them.
Whoa.
The evidence that we have of the diet of these whales is limited. We do know that they were eating fish, uh, large fish in many cases, large as a tuna. Uh, we know that they were eating each other in some cases, and we know that some of them also targeted sharks, but small sharks, perhaps,
Mm,
or even the babies of Otodus. But it's definitely not a matter of whales coming to the scene and wipe out the sharks, not at all.
mm,
More of the contrary. Sharks benefited from the inclusion of cetaceans into their environments.
mm.
Hmm. Did you start looking at this in your master's or just your PhD? Like, did you look at whales at all during your master's degree?
Uh, I started looking at them before.
Okay.
So in my undergraduate, I was doing geography. I did geography, and eh,
Let's go.
I was very interested in the physical geography, and particularly what can we know about paleogeography and the ancient environments. So my undergraduate thesis was a sort of compendium of what can we know about the Peruvian coast during the Paleogene period. So the Paleogene would be composed of three epochs. One of them is the Eocene, which is where all this whale bonanza happened. Um, but the first time is the Paleocene, in which we didn't have any marine mammals. And then comes the Oligocene, which is the start of the ice ages, or at least the polar ice caps. And it's the thesis was mostly aimed at collecting evidence from paleotemperature or paleo environments in the form of index fossils or guides to determine temperature, like some foraminifera, some barnacles, some oyster shells that are very picky with regards of their ecotope, and also association of faunas. There was an instance in which, what is the name of this? Mangroves. So mangroves were recovered in an area that is now a desert. Fossil mangroves, and mangroves are of course associated with very rainy conditions, very tropical environments.
Mhm.
And next to these mangroves, you do see turtles and sharks and these early forms of whales swimming. And so I became interested in that just by imagining how the coast would have looked like, so different from what we see nowadays. Later on in the masters, I decided to work specifically on paleontology, and the paleontology of everything that is a marine tetrapod. So tetra comes from four, tetrapoda. Poda means feet. So animals that have four limbs, or that originally had four limbs, that secondarily adapted to the ocean. And this includes whales, of course, but it also includes seals. It also includes penguins, crocodiles, turtles, some weird marine mammals called desmostylians that are completely gone. Um, I also looked at snakes and iguanas, and even a marine sloth, otters. And I did a sort of long uh, trend lines on their evolution. And my favorite part of it was discussing the whales. So I already was um, more or less obsessed with them by that moment. And now in my PhD, I was like, okay, I'm only gonna focus on these whales right now because that's what I really want to do, and that's what I can do the most because the amount of fossils that I have available in Peru to study
Mm.
is just a gold mine. It's absolutely baffling.
Wow. And does I assume the dry climate as well helps with that preservation. Would you say?
No,
No.
the dry climate is a wonderful thing
Uh-huh.
because it allows fossils to be found. But when in the time in which these fossils were first formed,
Uh-huh.
the the climate was not arid. We know that the Eocene was a tropical place. It was a tropical time.
Mm.
It most likely was considerably wetter than what the desert is nowadays. And we even know that the ice caps were not formed. We know that there were forests in Antarctica. There
Yeah.
were palm trees in Scotland. So it's a world that kind of looked like an oversized Caribbean. So imagine the tropical lines just expanding latitudinally. This was the Eocene world, and the reason of the preservation is not really associated with this. Is associated with the sedimentation rates. Uh, it's associated with volcanic ash and the specific marine environments that existed at the time in which these animals lived, which were, as far as we know, uh, embayments of shallow waters that were very likely safe havens for reproduction. So animals usually frequented these places and visited them to breed or well to give birth because it must have been protected from the open ocean and the huge influx of animals and also the huge influx of sediment coming from the early Andes, perhaps, or the volcanic chains that were forming at this moment. Because at this time, the Himalayas were really young, and the Andes were really young as well, and they were very, very small still. They were starting to grow. So all of this basically creates a perfect mix to rapidly deposit fossils, input a lot of or ash and nutrients into the water, which causes um, an overproduction of photosynthesis and bacteria, which
Uh-huh.
depleted the bottom waters from oxygen. So you don't get a lot of decomposition in there. So there's many
Whoa.
different variables to take into account. And this is what happens in Peru. I'm not entirely sure if this happens in Fayum,
Uh-huh.
uh, but we know that it was the case in Ica, at least. Ica is this southern Peruvian state, if you wish. So we don't call them states, but it will be the equivalent of state, um, which is completely desertic nowadays.
I kind of want to because we're all geography people. So I want to take a second. I want to just bust out. Can you see that okay?
Yeah,
There's a little map going on. Does anyone up opposed?
I love maps.
Yeah. Um, so you said that in this southern area, that's
Mm.
where you're finding a lot of these whales fossils.
Yes, but only in so you see the Andes, right? You see a
Yes.
huge increase of elevation. Um, I'm talking about the beige part, the closest part to the ocean.
Uh-huh.
And yeah, you do get some fossils over there, but most of them are a bit to the northwest in what is now Ica. So you're gonna see Ica, you're gonna see Nazca.
Oh, I know the Nazca lines. I know the Nazca lines. Um, okay. So, and it's just this
Yeah,
area. Is there not much kind of up north whale
it's very
wise?
different. It's very different because I mentioned these embayments.
Uh,
Ica was one of these embayments. It's a basin. It's a sedimentary basin, and it's very interesting because not only is biologically incredibly miraculous, it is also a geological miracle.
uh,
Because if you see the topography in the bottom of the ocean, the you can see that there is a clear line that is perpendicular to the continent, not
uh-huh.
parallel, perpendicular. It's
Oh,
going in that direction.
interesting.
That is called, it's like if you have the continent like that, you see the line like this.
Okay.
It's underwater. Do you see it?
Is it this one right here? Is it this
Nope.
or is
That
it
is that is the trench. That is the Peru trench.
uh
But I'm looking for something that is 90 degrees to that, like completely directed into the ocean. But you have to
Hmm.
zoom out a little bit.
Oh, I
Okay, do you
guess
see it now? It's gigantic.
maybe kind of like that.
Yeah,
Whoa.
but it's the shallow parts, right, that can be seen. And that actually is the trace of Easter Island. So Easter
Mm.
Island being a volcano
Uh-huh.
is a hotspot. So you can see the Easter Island. If you can you go to Easter Island?
Yeah.
Yeah, Tangaroa. So that traces the plate, the movement of the Nazca plate towards the shores of South America. And that rock is a bit lighter, is less dense than the
Uh-huh.
surrounding rock. So it creates a sort of it's a dorsal, it's a marine mountain range. And what it does is it creates a different angle of subduction in the plate right below Ica.
Uh-huh.
And this causes extension of the upper crust, which creates a lot of tension and normal faults that are subducted, are not subducted. They create grabens, so blocks of rocks that are just collapsing
Mm.
to gather a lot of sediment. And at the same time, everything is being uplifted slowly as the Andes rise. So we have the perfect combination of sediment gathering and then exposure in Ica. It
Wow.
was underwater up until very recently. And this is called the East Pisco Basin. There is also a West Pisco Basin, but it's still submerged. It's probably going to be above water uh, in many millions of years in the future, and it's going to be filled with wonderful fossils. But it's right now it's still submerged.
So a lot of these whale fossils are are like, do you think that there are species that we don't even know exist of whales that are just under the water?
Uh, well, you're talking about fossil whales that
Yes.
are yet to be discovered.
Yes.
Yes, probably millions of them, millions of skeletons, I mean. And when it comes to the ones that we already found, most of them are also new species. Most of them are endemic species that are animals that only occur in Peru, and more likely, uh, some of them are part of a South Pacific community
Mm.
that is considerably undersampled when you compare it to Northern Africa, Europe, or the United States,
Uh-huh.
which have a much longer history of scientific research.
Yeah.
Places like Peru are just emerging hotspots of paleontology.
Wow.
And this is what makes them a very exciting frontier because most of the things that are coming out of it are new,
Uh-huh.
and we can just see another window of what we think is happening in the north, and we can test hypotheses of what we think is happening in the northern hemisphere with the new material that is coming. We
Mm.
know that New Zealand has a lot of whales. We know that Australia has a lot of whales. We know that Antarctica has a lot of whales. The Seymour Island in the Antarctic Peninsula,
Mm.
it has Eocene deposits, and one of the earliest basilosaurs has been found in there. And we also get these weird things called the Kekenodontids in New Zealand, which is Maori for uh, very seal tooth from long ago, Kekenodon onomata.
Oh.
And it's very similar to a basilosaurus, but it's a bit more like the modern whales. So if you mentioned something like a missing link. There's no true missing links in evolution because it's not a straight line. But if we were to put or hypothesize how an animal would look that is right it is as distant to a basilosaurid than to a modern whale. It is perhaps something that looks kind of Kekenodon. Uh, and we don't really know much about it either. It's a very mysterious animal.
Mm,
Um, when it comes to intermediate forms, which do exist, uh, we get something very interesting happening in Peru. So I mentioned before that you get like two major epochs of Basilosaurid evolution. You get the latest Eocene, which is called the
uh-huh.
Priabonian, and you get the late middle Eocene, which is called the Bartonian. And the Bartonian is a bit older, of course. And what we see in Egypt is mostly from the Priabonian, from the later stages. What we are finding now in Peru appears to be early Bartonian, even Lutetian, which is even before. And in these early stages, we see a subfamily of Basilosaurus, a subgroup that basically was completely different from the rest of them. They may not even be Basilosaurus. They could be something
Whoa.
earlier. We're not sure, but it's possible. And what we're seeing in some of them is that they have long limbs.
Hmm.
So their limbs have not really been absorbed to the point uh, of classical basilosaurids, such as Basilosaurus itself, or the incredibly well-known Dorudon, which are animals that have very, very small and reduced hind limbs. I actually have here
Ooh.
a, a scan of the animal. So
I love
this,
these demonstrations also. It's so
can
good that you have all
Can you
this.
whip out the wave one more time? Yeah. Yeah. Nice.
so this is the humerus of one of the
Whoa.
whales I am studying. This is, of course, a 3D scan.
Oh, it's okay.
It's made of plastic. So humerus is the bone in your arm. It will be like this,
Yeah.
and you would expect whales that are completely aquatic to be uh, predominantly four-limbed, like their forelimbs, their arms should be considerably bigger than their hind limbs.
Uh-huh.
However, we not only have the humerus, we also have the femur, and they are sub-equal in length. And
Whoa.
this is very interesting because you are observing uh, a fully aquatic whale that had hind limbs almost as large as their forelimbs,
Whoa.
which is very weird. It's not something you see all the time. There is one whale, Cynthia cetus, which is the one that produced this model,
Yeah.
that has a very similar uh, proportion between the femur and the humerus, but and they are almost the same size as this one, but this animal is close to 30 feet in length.
Uh-huh.
And the animal that owns these two bones is more than less than a third of that. So it was definitely aided in some way uh,
Mm.
in
So he
in
was
its locomotion.
kind of goofy looking. He was a little goofy looking.
It is a bit goofy looking, yes.
Yeah.
It looks very awkward, and it looks awkward because there's nothing alive right now that looks like that.
Mhm.
And it's hard to picture how it moved. So
Yeah.
imagine a sea lion. Have you seen a sea lion swimming?
I I would say I have. Um,
They are extremely maneuverable. They
uh,
twist very fast, and they swim with their forelimbs like flippers. They like flying, but they
yeah.
also have their hind limbs to steer as a rudder. So I would imagine a sea lion but long, a very long sea lion with a tail, with a long tail.
Mm.
I picture this whale to be moving in a fashion that is reminiscent of something like that. Uh, so yeah, it's I wouldn't call it a missing link. I wouldn't call it an intermediate,
Uh,
but it is definitely the reason in which the way in which I would explain it is something that looks very derived from what you would expect an intermediate to look like,
mhm,
because it already has the features of a basilosaurid, but its hind limbs say otherwise. There is something called modular evolution or mosaic evolution, in which a part of the animal changes and another part does not.
mhm,
So, a good example of this would be perhaps the human anatomy itself. We have many instances of animals that, or well, hominins that already have a very human-like body, but have a face of a chimpanzee.
mhm.
And I'm talking like animals like the rising star, Homo naledi. So Homo naledi is a hominin that is very tall, but it has a very small head.
Uh-huh.
And then you get Homo erectus, which is also very tall. It's basically undistinguishable from us except for the size of the brain.
Yeah.
And then you get us, which obviously look like us, but we have a massive brain. And
Yeah.
this is sort of what mosaic evolution is in essence. It's much more pronounced in many different animals, but I think that uh, putting humans as an example is very illustrative. A part of the body changes a lot, but the rest stays. So actually, the our bodies or human-like bodies have existed for a long time. It is our brains that have grown and our faces that have become very small.
That's super fascinating that, not every animal is they're not obligated to evolve, everything. They could just keep what works and then say, "Oh, we
Yeah.
need to improve." Not necessarily actually, but like, "Oh, we need to improve in this department." Uh
Mm.
that's so fascinating. Um
Do you think there's any chance that a pod of those whales didn't evolve and they could still be out in the ocean today? Or maybe not directly from this whale family, but another creature like it. Could something be lurking in the deep?
The answer is yes. There is many things that are lurking in the deep that we know almost nothing about. The perfect example is actually, well, it is not a completely new kind of animal, but there is a family of odontocetes, of toothed cetaceans called the cepheids. That would be Ziphiidae, Cepheidae,
Defeated.
which are deep diving animals. They are extremely adapted to very, very deep dives. Some of them have reached 3 kilometers in depth,
Whoa.
or up to more than 2 hours, probably 3 hours. And these are extremely diverse animals. And there are some of them that we didn't really know, we didn't really knew how they looked until last year, because one of them was found dead. So there is still siphids that I think there is still a couple of species that we have either only seen dead or only have a skull of an individual that died and their bones washed ashore, and we haven't seen them alive like ever.
Hmm.
Uh, because they live 90% of their time is spent deep in the ocean and very far from the shore. So that does happen. in the case of my whale, sadly, um, their habits were most likely associated with very shallow waters. So they would
Mhm.
be very evident. They would be extremely easy to see if they were alive.
Mm.
Same with Megalodon. Like Megalodon, people say, oh, maybe there's a community of Megalodon deep in the ocean. No, Megalodon was adapted to hunting animals in the surface of the water, and animals like seals and baby whales. So Megalodon would be extremely visible everywhere if it
Mhm.
was alive.
What would you ever, what do you think bringing, let's say bringing your whale that you're studying, what if you do a woolly mammoth kind of thing? You bring it back to life.
I wouldn't think it would find any niche
Uh-huh.
for many reasons. So, first reason is that the world nowadays is very different
Uh-huh.
to the Eocene. So, the one of the major arguments for bringing back a woolly mammoth is that it would perhaps aid in the recovery of the boreal forests in northern Russia and in Canada, uh, and thus help sequester carbon dioxide from the atmosphere because these environments were extremely productive. So
Mm.
the mammoth steppe was an immensely large ring ecosystem
Yeah.
that sequestered millions of times more carbon than what the modern boreal forests do.
Uh-huh.
And the reason there are forests there is because you don't have mammoths. It's because you don't have mega herbivores that are restructuring forestal communities,
Uh-huh.
which is what happens in Africa, in the African savanna, with
Mm.
the elephants right now.
Mm.
And I see the point in that. But the Eocene was an ocean that was close to static. It didn't have the circulation, the thermohaline circulation that we have nowadays. And the primary productivity during the Eocene was not planktonic as is today with all the upwelling zones. It was more in the ocean floor. It was in the shallow oceans. So the animals that evolved in the Eocene would have a very hard time in modern day trophic networks. And aside from that, the reason why these animals were successful in the time in which they were successful, these animals meaning whales similar to what I'm studying and the protocetid whales, the amphibious whales,
Mm.
is because maybe we didn't have animals like seals. So seals did not exist in the Eocene. There were no
Mhm.
seals. And the job, quote marks, the job of the seal was being taken by these semi-aquatic whales. Most likely,
Mm.
they were around the same size and probably targeted uh, similar prey, and they were appendicular swimmers that swam with their four limbs, and some of them were very flexible as well. May have been swimming in a similar manner than a sea lion or a leopard seal and pinnipeds, which are the seals and sea lions nowadays, are extremely successful, and they would, I think, they would outcompete a protocetid whale that just started hanging out in their environments.
Uh-huh.
It's still a different animal because protocetid whales had massive heads and probably much greater bite forces, but
Yeah.
seals, on the other hand, are probably considerably smarter and more much more agile and nimble.
Mhm. And so you talk about how you know, you've gone down, you do research in Peru, and I think in the bar you may have told me a crazy story about, your research down there. Um, do do crazy things happen in the desert when you go out and do your research?
Yes, it's something that I it really depends on who you ask because
Uh,
to me, I haven't experienced the craziest things, but
mm,
when I tell some of the things that have happened to me, they are considered very exciting to people that have never experienced that.
yeah.
For instance, I can tell you that in one instance we were um, left without water for close to 5 hours in the heat of summer, and we were taking taking shelter from the sun right next to the car, and the car itself was very hot, and we were absolutely desperate. We started. I at least considered drinking my own urine at some point because it was several hours of absolute thirst, and you know what that is like
Whoa.
if you've ever experienced true thirst. But imagine that you just could not get access to water. Like there was no way, absolutely no way to get water, and it was
Wow.
very scary. And also in the same trip, actually, we got stuck in the sand, and it was very hard to move the car. So there was
Um,
at least a couple hours in which the car was not moving, and we had to go out and look for rocks to dig up the the tires and put the rocks in a specific arrangement so that the tires would better would have a better grip and then be able to take the car out. So, but yeah, that's something. Another story that my teacher could tell you is that they got lost for 3 days in the middle of the desert, and they
whoa.
they have been shot at in the desert. They have found uh, people walking completely lost with delusions in the desert.
What?
I have found, yeah, I just remember something that happened also. I found a dead body in the desert once of a girl. It was probably a teenage girl, and I don't know old how old the remains were, but it was a person. It was there. It didn't have clothes,
Wow.
so I don't know how old that is. It could be very old. I don't know if modern history would be the most likely explanation. It was probably several thousand years, but there's still the chance of it having been somebody who lived 200 years ago or less.
Wow.
I'm not entirely sure. It's very hard to tell. But yeah, it's finding
Do you think the
somebody.
girl was looking for whales?
Most likely not. I really don't think so. I really don't think so. It's likely that it was uh like the most easy explanation I can find is that she was probably part of a fishing of a community of fishermen or something that was traveling across the desert to like go from the valleys to the coast, and she just died in the way because that happens, and that used to happen in the past a lot. Because I don't know if you can put the map back, but
Yeah, of course.
I don't know if
Yeah.
you remember your hydrology, but
Mhm.
most most braided rivers are are those things that you see right there, right? That are perpendicular to the shore.
Mhm.
But if you go to Ica, if you go to the Ica River, most of it is not perpendicular. It's parallel to the shore.
Whoa.
So the people that were living in the valley had to cross the desert to get the fish, and they
Wow.
died a lot.
Oh my goodness.
And in that area you're watching right there, right in the middle, all of that is where the most productive fossil whale localities are.
Hmm.
Wow. And so it's kind of an open secret. Like everybody kind of know that this is the spot for whales?
Yes, it is very well known that
Mm,
it's high yielding.
mm,
But from knowing that to actually finding them, uh, that's a long trip.
interesting.
It's definitely not an easy an easy thing to do. And I can tell you that because I myself have been in there several times and I haven't really found much. Well, most of the times I go with my teacher, who is a genius, and he knows where the fossils are, and so he takes us to the fossils.
Mm,
Um, but yeah, if it depended only if it only depended on me, I would probably not be able to find not even a fraction of what he does.
wow. Because he's just been doing it for so long. Like he
Oh yeah,
knows the signs, he knows kind of that
he
that
knows
instinct.
exactly how the rock must look. He knows exactly what to look for.
Wow.
And it's just a lot of experience that they have to get in order to start getting close to that. Is absolutely fantastic what he does.
Awesome. Um, kind of a side note here. Did you ever like when you were younger, like were you a kind of a Google Maps kid? Like, did you go and look on Google Maps? Is that kind of how you chose geography?
I'm still a Google Maps kid. Uh, like when I'm well as a PhD student, I have a lot of things to do. I have many
Uh,
many different things to do. So I am very well versed in the art of procrastination. Uh, and and one of my favorite ways to procrastinate is to just explore random places in Google Earth, which is very uh, uh, it stimulates a lot of my brain because it shows like human communities, human culture. It shows geology. It shows biology.
yeah,
It yeah. So there's many things you can just observe in the maps.
yeah. I Yeah, I mean, I work for a geography. They don't know that I do this podcast, so I can say this, but um yeah, I do a fair amount of like, they'll see Google Earth open, they'll be like, "Oh, he's so productive. Wow, he's burning the candle at both ends." And here
I
I'm
mean,
in like I'm looking at like French Polynesia. I'm like, "How do they how do they get those boats there? How long is that boat trip?" So so it's a good time, man. It's real. This is real like grassroots education. This is.
yeah, I mean, one of the best ways to learn is via the play, and play is what we're doing when we're doing this. It's basically just exploration. Is looking
Mhm.
for things, just going and exploring anything that caught your eye. And yeah, it's a wonderful way to learn. It's just pure human fascination of the world in which we live in, and I think that's a very beautiful thing.
Yeah. Amen to that.
Yeah.
Zach, do you have as a fellow geography GIS, do you have anything to add?
Like, so I finished my. Well, actually, I feel like you'll appreciate this. I have a little whale story for you since we're on the topic of whales here. So I finished my master's in when was that? August. August. Yeah, yeah. My best stat that I've ever accomplished in my life: 3 whales, 3 oceans, 3 months. First one, we went to Hilton Head Island in the Atlantic, and like a baby humpback or a baby sperm whale like just came to shore, probably like 20 feet out, and it got stranded. It was alive. Then a week later, we went to Alaska in Katmai and flying in one of those boat planes. We saw a
Eh,
big humpback whale, like massive, just flying over like the glaciers and stuff. Very, very cool. And then, so that was Pacific Ocean. And then about a month later, I went on a really long like solo hike by myself, and I was in the Lofoten Islands in Norway. And there's this town called Svargen, and I was just sitting at this radio tower probably for a week. I was told there was orca whales there, and that was my only goal in going there was to see them. I probably sat at this radio tower that like 360 looked at the ocean probably for a week, 8 hours a day. I was about to give up on the eighth day. Pod of orca whales showed up just off the coast.
ooh,
It was the best moment of my life. But
beautiful.
seeing your little orca toy, I was like, that
Eh,
that brought me back to my happy place. Look, exactly. But
Oh,
aren't orca whales not actually whales? Aren't they like part of the dolphin group?
they are dolphins. They are gigantic dolphins.
whoa.
Yeah, but dolphins are toothed whales. So everything that is a cetacean,
Mm,
objectively speaking, can be referred to as a whale. Because if you say that the sperm whale is a whale, and you also say that a blue whale is a whale, you are saying that all the descendants of the common ancestor of sperm whales and blue whales must be whales in order to make sense evolutionarily.
mm,
Um, so yeah, technically, if you're talking about whales, you're talking about cetaceans. But if you want to make the definition a bit more liberal, you can ask marine biologists, and marine biologists will tell you that large body cetaceans are often referred to as whales, and that includes orca.
Are manatees and what dungoons? What are the exact
Dugong.
dugong? Those are cetaceans or those are not
No,
cetaceans? Okay.
those are not cetaceans. Those animals are uh, part of the African mammals, those the Afrotherians. So the group that includes manatees also includes elephants, also includes aardvarks, and also includes
Whoa.
the rock hyrax. And it is a completely separated family tree. The whales, the true whales, are related to the even-toed ungulates, such as well the hippos and the pigs.
Mm.
And this is a completely separate branch of the placental mammals. Because yeah, if you're dealing with mammals, with mammalia in general, you have the three branches, right, which are the marsupials, uh, kangaroos, your koalas. You get your monotremes, which are your platypus, echidnas, and you get most of them, which are the placentary mammals, the ones who have long pregnancies and give live birth. Um, those mammals, the placentary mammals, are divided into four major groups.
Mm.
Uh, the whales and actually the primates, us, and the lions and the dogs are all in this huge grouping called the Laurasia um, which is thought to have originated in Asia. And this and the other groups actually include, well, there is another group that is closely related to this one, which is the Archontoglides, which are us and rodents. And both groups together are called the EU. No, wait, I have my mammal taxonomy wrong. Those are called the Boreo right? The other branch of the placentals are called the Atlantogenata and include the Afrotherians, such as elephants, manatees, and also include the Xenarthrans, which are your anteaters, your sloths, your
Mm.
armadillos. So whales are more closely related to a mouse than they are to manatees.
That's that's so crazy.
Yeah. And also, but because they are even-toed ungulates, whales, a sheep or a goat is more closely related to a whale than to a horse.
Wild.
It'll it'll means shared ancestry. It's part of their shared evolutionary history that sets them apart.
So is it great when you have other people around that who are like learning about whales and are, you know, professionals in studying whales? Is it great to like, you guys just to sit around together and just kind of talk about whales? Is that a good feeling?
It is. But it has become so frequent that it's literally my Thursdays. That's what I do on Thursdays. That's my lab meeting. Uh, so yeah, of course we talk about many different things, right? But everyone has at least something to say about whales
Yeah.
every week, and of course I like it. It's interesting. It's what I do.
Yeah.
But yeah, I actually prefer to do something like this in which I can talk more about it myself and and
Yeah.
yeah, because most of the things that I've mentioned today are pretty much, well, I wouldn't say obvious, but pretty much the day to day in the lives of people who research whales,
Uh-huh.
and and it's refreshing to get excitement as a reaction to that.
Awesome.
What's I got one more, or however long you intend
Yeah.
to do this. The Has there ever been a big argument for whale? Like you're in the lab, someone says something controversial about a whale. Like what are y'all fighting about? What's the statement that triggers the whale community?
I would
Or
say
is
there's
everyone just
there- there's
nice?
one there's one argument that is really making a lot of people very angry, and not within my lab because I wouldn't say there is anyone in my lab uh, that has a specific viewpoint uh, on this that is their research. So it's something else that we know about, but we don't actively research that. So what we do is pretty much, or at least what I do is pretty much exploratory, is trying to discover new things. But um, the most controversial topics arise when you have something that is very well known and you're trying to explain it in a novel way. And what gets most attention is perhaps the evolution of baleen, and what is the correlation in the skeleton for baleen. So baleen being this sort of plates in the mouth of filter feeding whales that are made out of keratin and that grow from their gums. And the origin of this feature is something that has a lot of people against each other, because some people say that it is easily correlated with something called the palatal grooves in the bones in the palate. Actually, I have a So this is an
It's
odontocyte,
amazing.
right? This is an odontocyte skull. This is the ventral view. So this is from below. And if this this is the palate, right?
Oh.
So the top of the mouth. And in whales that are filter feeding, you get very deep grooves in here that are associated with the vascularization of the tissues that give rise to the baleen. And some people say that they are a clear evidence of the presence of baleen in fossil taxa and therefore a good indicative of when it evolved. However, a lot of people, which are actually more closely related to the people I interact with on a daily basis. So this is the view of people that have come out of my lab, is that it doesn't mean that baleen is growing. It is just innervation to the gums, but it's not necessarily uh, indicative of the presence of baleen. And this is mostly because it has been found to occur in toothed whales that are not filter feeders. And to me, that says that is very solid evidence that you cannot rely only on that to expect baleen in a fossil animal. But a lot of people are convinced otherwise. A lot of people say that the anatomy of the grooves is different, the
Mhm.
innervation is different, the deep canals inside of the maxillary bone are completely different. So it's a huge deal. It's a very complicated argument, and it's also a very interesting argument because um, the origin of baleen is very hard to pinpoint because it doesn't fossilize. It does fossilize in some uh, exceptional conditions, but it's very rare.
Amazing.
Wow.
So I
Um,
would say that is one of the biggest debates that are taking place right now.
Interesting. Um, I do I don't mean to switch the topic, but I kind of want to talk about this and then kind of come back to, I guess, kind of to round it out. But uh your love of ACDC, I guess. Um, what kind of what kind of music would you say you listen to? What's your vibe in the lab that you're listening to? How did you get into like kind of, I guess, rock music? Or
Well, I have my mother to thank. Like my mother is really fond of rock music in general, and um, so every summer we we go to this place uh, a bit to the south of Lima
Mm,
that has very beautiful beach clubs, and we always spend our summers in a beach house along the coast, uh, which is like a they are like very small towns that are created in the shore, and it's very nice because there's lots of close friends. And like
mm,
Lima is a gigantic city. It's over 12
yeah,
million people. And of course, sometimes it would take an hour to or more to just go from one side of the city to the other. Uh, and some people live 1 hour away in the city. So you never see them. You never see them, and aside from like weddings or birthdays.
yeah,
And when you and a lot of people that I know actually do have the same customs in the summer. So we all go to these small towns in the shore. So friends that normally would take a special event to see are just walking by your sidewalk during the summer because we all go to these places.
yeah.
And the trip to those places uh, is like 2 hours from
Yeah.
Lima in the highways, and it's very hard for me to think of a time in which in which I have that done that trip without listening to rock music since I was a little kid. And yeah, it was all my mother's. It was all my mother's fault. Like contrary to what you would assume, perhaps my father doesn't like rock at all. He hates it. He
Whoa.
he prefers uh, Italian music and
The Bad
well
Bunny. You
he
like
he he likes the Beatles. He likes the Beatles and the Beach Boys, but rock that is more like crazy, like hard rock,
yeah.
he is not for him.
Mm.
He's a bit too he's a bit altered by it. He is disturbed by it. But my mother, on the other hand, she's very rock heavy
Awesome.
oriented. And
Little little Deep Purple, a
oh
little
yeah, yeah. She loves
Guns N'
Metallica,
Roses.
Guns N' Roses, of course. For my father, it would be just uh, people screaming.
Wow. Um, so Zach, you got anything, Zach? Or I got
That was just, I think it was just perfectly described. Like, it's a beautiful story.
Yeah.
There's nothing else
You
to add. Like,
you
this is
are
perfect.
you are a very good storyteller, I must say. Like,
I enjoy telling stories. I think it's one of the most uh, beautiful things about humanity,
Mhm.
telling stories,
Yeah.
That's what
sharing,
geography
sharing.
is.
Yeah, share it. That is what we are. It's sharing. It's trying to make the other person feel like we felt during that moment. Uh,
Uh-huh.
and it's a very magical thing. And I've always admired people that are able to produce those feelings in me. So I well, I strive for being able to do it as well.
Awesome. Yeah. That's I've always been fascinated like ever since I was a little ever since I was a Boy Scout. Um Also, my parents would always have talk radio on and so I'd be listening to that and I've always been, you know, Boy Scouts sitting around a campfire listening to people tell stories and you know, it's always been, I've always, whenever I played a video game, I've always been fascinated in what the story is, you know?
Mm.
So, um,
What's your favorite video game?
ooh, I would say, I love like BioShock Infinite. I love one of the map games I like is Age of Empires, but that's
Hmm.
a little too stressful. Um, yeah. So, what about you?
Well, I really enjoy this game called Avatar: Frontiers of Pandora. Uh, so it's of course set in the Avatar universe, but
Yeah.
it's not about the movies. It's completely disconnected from the storyline of the movies,
Mm,
and it is the most beautiful thing I have ever seen when it comes to gaming. It's the floating mountains and the
yeah.
plants and the animals and the colors is so vibrant and so alive, and it
Mm,
is extremely easy to just forget about the mission and just walk around and observe.
mm,
And it's completely open world, so
yeah.
it's very interactive.
And
And I
now
love it. I absolutely fell in love with that game.
I'm gonna have to give it a play then.
Oh yeah, yeah. And the music, the music is a absolute masterpiece. Is different from all the music in the movies, but it's the same
Uh,
style. Like the person in charge of it, her name is Pinar Toprak, I think.
uh,
Uh, she, I wouldn't say copy because it's not copying. She put herself in 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 the role of the original composer for Avatar, and
Whoa.
she did the same style, the same energy, but completely originally, and differently. So it's absolutely fantastic. It's I think she's one of the most important factors in my experience.
Right on.
It's absolutely wonderful. I that is the game that has made me shed a tear.
Whoa.
Absolutely. Yeah.
Um, yeah, man. I mean, I think the Avatar universe kind of encapsulates as well. Um, people came out of there and they're like, they got the Avatar. I don't know if you heard of that. They got the Avatar post-Avatar depression where
Yeah.
they're like, oh, it's not as beautiful as an Avatar universe. But I think, you know, if you look at the whales, I think it can be as beautiful, if not more beautiful than the Avatar universe. And
I completely agree with you. And one of the actually and I can speak about this because I myself have experienced this it's like a drug, because
mm,
when you the the horrible depression that people get after doing a drug is because they run out of dopamine.
yeah,
They are so overstimulated that their dopamine receptors are completely shattered, and they cannot get that satisfaction anymore for a while. And the same thing happens with Avatar. Is the visuals are so vibrant, the intensity of music and emotion in many of the scenes is so intense
yeah.
that after you walk out and you see a parking lot, you're left in a state of what the fuck is this? Like I want to go back. I want to go back to the cinema. I want to go back there. And it happened. It's very real. So it like people feel weird after watching movies
Yeah.
sometimes. And with Avatar, in my case, it lasted for like a week. Uh,
Whoa.
and the way in which I got out of it was basically my job, was paleontology, was uh,
Wow.
reading about the natural world, investigating the animals that were here for real. And of course whales are the perfect example of this because they whales inspired the second Avatar movie. uh, and they are, of course, animals that have social bonds. They are animals that sing, that have emotion, that have very complex social structures and feelings. And that is precisely what we see. And most people perhaps forget that Pandora and Avatar is basically referencing Earth. So
Yeah.
we are supposed to remember how beautiful the world that we live in is by watching those movies, not be disappointed by it. I think that is the goal that is trying to remind us of.
What do you think, um, I guess with whales, they're just such a unique creature, with it's unlike any other. It's like you were saying, the singing, the dancing, the sheer size that the largest mammal um lives in the ocean, and it's occasionally comes up to greet us and grace us with its presence. And so um there's just such a mystique with the whale, incredible mystique. And I was just wondering, like, what do you think, what would you like to leave with the people about whales? What's your take?
Well, there's many things I would like to live everywhere with. uh, like one of the things I like to think about is that for most of their history, they were the most intelligent animal on the planet.
Oh,
And like cetaceans were most likely uh, the most intelligent animals on the planet until uh, the hominin, the human-like uh, animals evolved. I do think that animals like sperm whales could be more intelligent than chimpanzees, for instance.
uh,
There is, of course, eh, many sorts of difficulties if you want to demonstrate this, because the intelligence of a chimpanzee is very much like ours, so we recognize it more easily. But we know so little about the intelligence of animals like a sperm whale because they are very hard to observe in most of their activities.
uh,
That is hard for us to really grasp what kind of intelligence, in what shape its intelligence is, in
wow,
what way they perceive the world. But what we do know is that they have grammar. They have grammar, they have dialects, they actively coordinate, and the the sounds they make are something that kind of resembles out of science fiction. Is
whoa,
completely cryptic yet. Uh, so if I had to say something about that, would be that it is possible, like the closest we are to interacting dialectically with another species is via whales.
wow,
And it hasn't happened yet. And if you could be reminded of something like Coco, or the gorilla Coco. But Coco was replicating human language.
uh,
But this communication in sperm whales is not human language, it's sperm whale language. Coco was trying to be human in the way in which she communicated, but this is another form of language, another completely different origin of complex, perhaps even abstract communication. And we don't know almost, we know almost anything about it. We know so little about it. And it's just fascinating to think about what we don't know yet about that.
uh,
Uh, and yeah, that's just one of the things about whales that are interesting. I haven't is the first time I mentioned that in the past hour, and and I believe it's one of the things that I wanted to talk about with, and didn't really get the chance to. But
uh,
yeah, they are there is something that I really value about people like the Polynesian communities, because they want to grant personhood to whales. They want to
wow.
give whales the same rights that humans have. And I think they are very wise to do that.
I I think that's that's that just shows the if that doesn't drive home the point of the whales and how incredible these creatures are, um, I don't know what would.
Yeah, we haven't even talked about ecolocation. We haven't even started. Like everything that we've talked so far is very interesting, of course, but there is
Mm,
so many tangents that could be driven from whales. Whales are a topic that we know a lot about, but we know that there is so much more that we don't know yet, and
wow.
and all of it is absolutely fascinating. I think they are the most interesting animals on the planet. They are larger than the dinosaurs, probably smarter than chimpanzees. They are in every single ocean, visible from every shore in the world. Everybody knows them. Everybody likes them. I think it's just the most interesting topic in the world.
Wow.
And,
Yeah,
and and you can make a case for that. I could write an essay saying why whales are the most interesting thing in the universe.
wow. Yeah, you do never meet anyone who's like, yeah, I don't like him.
Yeah, yeah.
Yeah.
Who says that? Have you ever met somebody who says dolphins? No, I don't like dolphins. No, or
No.
whales or jumping, singing humpback whales. No, I don't like that. No, it's not possible. People don't do that. They are inherently charismatic and beautiful to all of us because perhaps because we know they are smart and they are as smart as for us to be so interested about them, but only by like the same even the shape of them. They look like a fish, but they are bigger than dinosaurs. And it no, it's just there is so much to talk. I could go for hours and hours
Yeah.
nonstop.
Well, we would definitely, I mean, we would love to have you on again. If you're willing to come on again.
Oh
Um,
yeah,
yeah.
yeah. Perhaps we can do one about dinosaurs.
Oh, that would be incredible.
I would love to talk about dinosaurs again.
All right, Piero, thank you so much for this. This has been a lovely conversation.
It has been indeed.
All right, dude.
I've enjoyed it a lot.
All
Thank you
right.
for teaching us the ways
Yeah.
of the whale.
The way of water.
Yeah, yeah.
Absolutely.